Hello, and welcome to the second installment of our summer series, TCDI Talks, where Altumatim and TCDI are talking all things GenAI. I'm David Gaskey with Altumatim, and I have with me today David York and Caragh Landry from TCDI, along with Vasu Mahavishnu from Altumatim. So last time we spoke a bit about GenAI more generically, just approaching the idea of what is it. Today we want to talk about the approach to it. Now, one thing we've realized in working with GenAI over the last couple of years is it really is a different technology. It's got different characteristics and different behaviors. So we realized that it requires a different approach. A phrase that we often use talking about our approach is that we treat GenAI more like a human than a computer. You might be wondering, what the heck are we talking about when we say that? Well, we're happy to answer that question. So I'll open it up to our panel. Who would like to begin to explain what we mean when we say we treat GenAI more like a human than a computer?
I vote Vasu. I vote you start.
We tend to want to. So in the traditional sense of using a computer, we like, for example, a calculator. For example, let's just take a calculator. You punch in a few numbers, you get back an exact result, right? So it's 100% accuracy. If you use an LLM to perform a 3-digit multiplication, is going to get it wrong 70% of the time, or even higher than that, because it was not trained or built to do something like that. It's trained on data that is using language, and its purpose is not to calculate, math. So there is obviously accuracy issues and consistency issues with large language models. But we don't interact with the calculator and we don't speak to it. We don't say, hey, can you multiply these two numbers? We have to actually punch the numbers in. So the way we interact with it compared to a large language model is very different, because we actually use human language to interact with it. So we feel that because of these inaccuracies, and much like humans are not accurate, because when you ask a question to another fellow human, they may not have all the answers, and they may be guessing, they may be retrieving the answer from memory, or they may be adding their own reasoning and answering you. There's no certainty that the answer is correct.
Or Vasu, more likely, they're basing their answer on the documents they've seen so far, right? So they're learning they've experienced so far, which is a reason why we add QC and validation to all of our processes, is because, our QC team has seen more, right? So they're basing their answers on a very small percentage.
Right. So if you're in a room of individuals, I'm not talking about LLM, you're in a room of 20 people and you ask a question to an individual. And if they ask that question and they answer the question, well, you can get the response from the other 19 people, whether the answer was right or wrong. And if it's an opinion based, well, that may result in a room that's divided with the answer. So that's much like how a large language model behaves. It's not quite right all the time, but you will need to evaluate that answer.
In terms of that evaluation and what you were just saying, Caragh, it sounds to me like not to say that an LLM thinks like a human. So let's take the review process during e-discovery. If you have a human reviewing documents, you tend to give them some to start with, right, with a review protocol, but then you want to, at some point early in the process, check in on them, see how they're doing. Are they understanding things correctly? And it sounds like we need to do a similar thing with LLMs.
Yeah, absolutely. So that I think was and I think we mentioned this in our first talk, but that was our biggest learning experience from employing Gen AI in the review process, was that it's not just a one and done. You don't create a prompt based on what you think and you send it through, and then you get a result back, and the result is going to be great. If you expect the result to be great, it's really naive, right? You look at the results, and it's going to get a lot of things right, but it's also going to get a lot of things wrong, just like a review team would, right? In a traditional process, you get the attorney team on with the TCDI review team, the MSMR team, and the attorney team, outside counsel, trains us. We understand it one way. We're applying that understanding to documents one way. It may or may not be the way outside counsel needs us to interpret those documents. So they give us feedback. We retrain our team. We look at examples, and then we refine our understanding, and now we apply that understanding to the next set of documents. Very similar using Gen AI, and especially working with you and your team, is that it's not one and done. It's an iterative process. It's about creating good prompts that are going to get you good results, and then validating and QCing the result and refining the understanding or the analysis that your product or your tool is able to do, so that we're getting better results with each throughout the process.
Right. So when we say that we're treating the Gen AI like a human, we're not really saying that the Gen AI is human or even has thinking capabilities or reasoning capabilities as a human does. But there are similarities, and that's why the similar approach that you just described with the human reviewer, that's why it is effective with using Gen AI, because the people refer to the reasoning capability of LLMs, and it's not pure reasoning in the sense of a human reason. Like Vasu's example of the 19 people in the room, everybody would apply their own reasoning to giving their opinion on answering that question. So, but what an LLM does have, I mean, there's within a neural network, there are layers, and it can analyze things and detect things like hierarchical relationships among data points. So being able to connect those data points, if you guide it properly, it resembles a reasoning process in stitching together those data points. So there are definitely similarities that when you take this approach, you do get much more effective results.
Yeah, I think one interesting thing we've learned, with the Altumatim TCDI work is that it's very much a process. It's still a process. It's not just throw data and questions at something, get back results, and move on. But just like with human interactions, and I'll use the 19 people in a room example, we wouldn't walk into a room with 19 people, give them a review protocol and 100,000 documents and say, have at it. There's a distinct process that is followed with that human interaction. We sit there, we go through training with them, they ask questions, we give them feedback, because all 19 people coming into that room have a different base level understanding of the content of, different concepts that are being handled. And so, those inputs and the feedback that we get, it is very human-like, because we come, a lot of us come from a world of database prompts to where, you're building out very specific queries that are not how we talk, certain words within 5 words of this, and or you're building out all these complex Boolean logic statements to find documents that you're looking for. Whereas with this, we can ask very conversational type questions, and then based on the process that we go through, that's going to drive the answers and results that we get, just like it would with a human. A key difference being, computers can read 10,000 documents a minute, humans not so much. So you can get to answers quicker, and you can get to the understanding of why it made the decisions it made. Because to Kara's point earlier, I think that that's key compared to some of the legacy AI tools we've used over the years. Because even with Boolean logic searching, you can sort of dive in and say, okay, why did I get the results that I got? You can start analyzing and looking to see that you need to tweak, add a wildcard here and additional terms here to get the results that you want. But, with traditional tar and other things over the years, you're just relying on scores as opposed to getting an explanation of why the machine made the decision it made, just like you would with a human. You can actually see its reasoning. Those 19 people in the room, you could sit down with each of them and say, okay, why did you make the decision that you made on this document? Why did you code it this way? And then you can make that correction, give them that feedback. So that if they're wrong, they know how to be right going forward. And that's very much how the LLM interactions seem. It's very process driven.
All right. Well, hey, Dave, Caragh, Vasu, thank you so much. We will be back. We have more issues and topics that we are very interested in discussing, but we want to hear from you. If you have an issue, a question that you want us to cover, please reach out to us. We'll be happy to cover that in a future episode. And for now, we'll say goodbye.